Hello everyone, today we're going to look at this problem. It's slightly long, so let me give you some time to check it out and think about it. This problem is slightly more challenging, not because it's complicated, it's simply because it's not as clear on what comes first, what comes next. Or in other words, basically the sequence of events is slightly more ambiguous. Okay, so it takes some time to tease out what happens first, what happens next. Okay, so I would encourage you to try to solve this problem on your own before you watch the following video to find out the solution. Okay, let me assume that you have tried it out. Let's move forward to solve this problem. Okay, so let's think about what's the first thing that happens, first event. Again, events are either decision or uncertainties. Now we're going to build a tree, and remember there are three steps in decision tree. First, you build a tree from left to right. Second, you provide the payoffs for each possible outcomes. Third, you fold back the tree to find out the optimal solution. So what's the first event? Well, basically this person, Mike, he can choose to sell his crops right now or he wait. But if he waits, there can be a chance that the storm will hit. And the outcome of when the storm come or not really depends on whether he protect his crops or not. If you put this together, basically that tells you he needs to make a decision right now, and there are three options. First, you can say, okay, so I can harvest now, and that's it. And the problem of harvesting now is the price is not as good. Actually, the price is pretty low. Or he can opt to going for a higher price. That means he waits. But if he waits out the storm, then he need to decide whether he wants to protect the crops by waxing them or not. So in other words, there are two other options. First, he waits and protect the crops, or he waits but he does not protect the crops. So now we have three branches. We need to simply follow every branch and think about, so what happens next. If he harvests now, then that's it. End of story. If he protects, then what's next? Well, he will figure out whether there's a storm or not. Okay, so that means the next event is an uncertainty. Here's a storm with two possible outcomes. Storm may come or the storm doesn't come. Okay, so there's storm or there's no storm. This is a circle, so don't forget that we need to provide the probabilities for each possible outcome. The problem says that the chance of having a storm is 50-50, so that means the probabilities are 0.5 and 0.5. Now let's look at this branch. What happens if the storm hits? Well, the problem says even if you protect, there's no guarantee that there's no damage. There's still a chance that damage can happen. Okay, so there is a chance that damage can happen. A chance. So that means it's a uncertainty. Okay, so I'm going to give you a circle, two outcomes. There is some loss and there is no loss. And the probabilities for those two are 0.6 and 0.4, which is given in the problem. Okay, good. So now let's just follow the branches. Okay, still, let's start from the top branch. If you protect, there's a storm, and then actually a loss happens. What's the actual amount of losses? Well, the problem says, you know what? In this case, there are three possible outcomes. Okay, so that's an uncertainty with three outcomes. You can salvage 90% of the crop, salvage only 75% of the crops, or you salvage 50% of the crops. And the problem says the chance of each occurrence is identical. They are equally likely to happen. So that means the probability is just 1 divided by, there are three outcomes. So 1 divided by 3, 1 over 3. So that's 0.333. Okay, and is there any next event over here? Well, no, that's it. Okay, so we know we reached the end of the story. Now move on to the next branch. If he protects, the storm hits, there's no loss. Is there any further events? No, so this is the end of this branch. Move on to this one. If he protects, there's no storm. Is there any further event? Turns out, yes, there's a problem. Okay, so it says that in this case, there's a chance that there is some residue problem. There's a chance. So that means this is an uncertainty. So I'm going to use a circle with two possible outcomes, whether he has residue problem or no residue problem. Okay, and is there any further event if there's residue problem? Well, it turns out no, so this is the end of the branch. What about this one? There's no further events as well, so that's it. So we can move on to the next one. Oh, sorry, before we move on, we need to give the probabilities. They are 0.3 and 0.7 given in the case. All right, so let's move on to this one. If he does not protect the crops at all, what happens? Well, the next thing is simply he will figure out whether there is a storm or not. So it's an uncertainty with two outcomes, storm or no storm, with equal probabilities. So at this point, we have finished the first step, constructing the tree structure. So now we can move on to step 2, providing the payoffs for each possible outcome. In this problem, what is this person Mike tries to do? He tries to maximize his profit. Okay, so he's trying to maximize his profit, so we're going to use profit as our payoff. Let's start from here. Harvest now. So what's his profit in this case? We know that if he harvests now, the profit margin is quite low. It's $0.05 per pound. But the upside is that he can harvest all of his crops. So his profit is simply the margin times the total amount of crops. So comes out this number. Next case. He waits and protects. The storm hits. There's some loss. He can keep. In the first case, he can keep 90% of his crops. And he can sell the crops at a higher profit margin of 0.15 per pound. So that means his profit is margin times 90% of all crops. Okay, comes out this number. Next case is similar. The only difference is instead of 0.9, it's 0.75 here. Next one is similar, except that this is 0.5 instead. Okay, so these are the profits. Here, if he waits, storm hit, fortunately no loss, that means he can sell all of the crops at the full profit margin, so this profit. If there's no storm, but there's residue problem, the case says that he will lose some crops. So actually he will keep only 80% of the crops in this case, so this is a profit. If there's no residue problem, then that's great. He sells all of the crops. If he doesn't protect, the storm hits, the case says that he only can keep 10% of the crops. So he sells 10% of all crops. So this is the number. Otherwise, if there's no storm, that's great. He sells all the crops. He can retain all of the crops and sell them at the higher profit margin. So this is the second step. All right, now move on to the third step. We need to fold back the tree to find out the best decision. Okay, when you fold the tree back, you start from the nodes on the right. You start with the nodes that do not have any following nodes on their right. Okay, that means we are probably going to start with this one. But first, again, let me label the nodes for ease of reference. So starting from node 1, it's a circle. A circle means we need to calculate the expected value of the payoff. Okay, so the probability of each branch is 1/3, and these are the payoffs. So what you do is probability times payoff plus probability times payoff plus probability times payoff, and that's here comes out 86,000. So I'm going to copy this number over here, 86,000. Again, what does that mean? It means if he ends up here, specifically, if he tried to protect, if he choose protecting, the storm hits, there's no loss, there's some loss, then on average, his profit is $86,000. Okay, this is his average profit. If he protect, the storm hits, there's some loss, but you don't know what kind of loss it is. Okay, so that's this one. Now we can move on to the next note. Again, it's a circle, so we do probability times payoff plus probability times payoff. That comes out 99.6 thousand. Okay, I'm going to copy this number up here again. Again, that means if he chooses to protect and the storm hits, then on average, his profit is going to be this number. Now I'm going to move on to note 3 because I cannot analyze note 4 at this point because I need note 3's number. Okay, so again, probability times cost, payoff plus probability times payoff comes out this number. I'm going to copy it over here. And then now I'm able to analyze this note. Circle, so again, probability times payoff plus probability times payoff. So let me explain again, why are we doing this number, probability times this payoff? Because probability is just probability, but if the storm actually hits, what we learn here is then his expected profit is going to be this number going forward. If there's no storm, then on average his profit is this number going forward. Okay, so we do the expectation calculation over here, and that leads to this number. I'm going to copy it over here. Basically, this number is the expected profit if he protects. Now move on to the last note. Again, it's a circle, so we do probability times payoff plus probability times payoff, which comes out 66,000. I'm going to copy that over here. Finally, we can move on to the first decision note. This is the only decision note. Decision note, a square. So when you have a square, all you need to do is to compare among the following branches and find out which one is the best. Harvest now give you $40,000 in profit. Protect give you on average 106,200 as profit. If you do not protect, this is your profit. Apparently, this number is the largest, so that means he should choose to protect. That gives him the highest profit. And again, I'm going to move this number over here just to remind myself this is his expected profit under the best decision, and this is the complete analysis of the tree. Now that we have analyzed the tree, we can answer the case questions. The first question asked, what is Mike's expected profit if he harvests now? What is his expected profit if he does nothing and waits out the storm? Okay, so if he harvests now, okay, it's already, that means he choose this one, then we find that his profit would be $40,000. Okay, that's it. Next one, what is the expected profit if he does nothing and wait out the storm? So that means he choose this branch, not doing anything and wait out for the storm. And in that case, his expected profit is this number. So that's the answer. Okay. Second question. First, is it a good idea for Mike to protect his crops? Well, apparently, yes, we already solved that. How do we see that? Well, here is it. There are three options. Harvest now, that gives him this profit. Protect, giving him this expected profit. No protect, giving him this expected profit. Turns out protect gives the highest expected profit, so yes, he should. What is the max amount that Mike should pay for the protection given that he chooses not to harvest now? So if he does not choose to harvest, now, that means he either protect or do not protect. Okay. So and what is the max amount he should pay given that he choose not to pay for protection? So basically that means The value of protection is simply the difference between these two numbers. Okay? Because protection give him a higher payoff, but if he doesn't protect, he can also give this expected profit. So that means he should pay no more than the difference of these two. And the difference of these two is basically the value of protection. Okay, and that comes out this number. Okay, so he should pay no more than the difference between protection and no protection at all. Okay, and that's $40,200.